So back to our favorite picture where we do the steps of a DNS lookup. Now we'll do the same thing, but every name server gets split into 2. So we're actually going to somewhat rewrite the first problem now. It's still part of the same DNS lookup. So you could probably write this as, what's the IP address of eeks.berkeley.edu? But I think a better way to write it would be something like, what are your public keys, for reasons that we'll see soon. But it's still the same lookup. I still want to know the IP address of eeks.berkeley.edu. So we ask the upper half for its public keys. And the upper half says, here are both of my public keys. I have an upper zone and a lower zone. So my upper zone is the KSK, the lower zone is the ZSK. And I'm going to use my upper half private key to sign my lower half public key. So in other words, the upper half is endorsing the lower half. So here's the signature on my lower half key. If you trust my upper half, now you trust my lower half. And I do that using an RR-SIG record because I'm signing something, and specifically the thing that I'm signing is my lower half. So another way to read these 3 records. Here is the thing I want to sign. It's the lower half key. That's what I want to delegate trust to. Here's an RR-SIG to delegate trust to that lower half. And here's my upper half public key, so you can verify the signature. So it's the same 3 records we've always been seeing. Here's the next name server's public key, no hash this time. Here's the signature on it, so that you trust them now. Here's my own upper half public key for verification. So it's delegating trust to the lower half. So now we go to the lower half, which is the same name server, and we ask them the IP address of eeks.berkeley.edu. And they reply by saying, I don't know, here's the next name server, same old NS record, same old A record. And I'm going to sign the next name server's upper half. I'm going to sign their KSK. So now, if you trust my lower half, then you trust the next name server's upper half too. And we do this by issuing a certificate. It's the same old certificate. Here is the DS record with the next name server's upper half public key. And here's the RR-SIG signing that next name server's upper half public key. So these 2 things delegate trust to the next name server's upper half. And if you want to know the ZSK for verification, well, it was attached right there, so we don't have to send it again. So it's basically the same thing happening over and over. We're just splitting name servers into 2. So now we go to the .edu name server. We ask the same thing. What are your public keys? Here's the upper half public key endorsed by the previous name server. It's going to sign the lower half public key. So now if you trust the upper half, which you do from the root, now you trust the lower half too. This signature passes trust from the upper half to the lower half. And here's the public key of the lower half. Then we ask the lower half for the IP address of eeks.berkeley.edu. Same old NS record, same old A record. Here's the next name server to talk to. Here's a DS record and an RR-SIG record to pass trust on to the next name server's upper half. Then we go to the next name server's upper half. They endorse their lower half. And then we go to the final name server's lower half. We ask for the IP address. Here's the answer. Here's the RR-SIG as usual, so that you can verify this answer. And after all that pain, we're finally done. It's a little bit unintuitive, and it's all in blue, so I don't care if you actually know it. But in case you're curious, that's what real-life DNSSEC looks like.